Welcome to Astronomy Daily, your source for the latest developments in space exploration and astronomical discoveries. I'm your host, Anna, and we have a packed show for you today with some truly fascinating stories from across the cosmos. We'll be diving into SpaceX's upcoming 9th Starship test flight, which represents a major milestone for the program as they attempt the first reuse of a super heavy booster. Then, we'll explore a surprising discovery about galaxy evolution. Astronomers have found a massive galaxy that mysteriously stopped forming stars when the universe was just a cosmic toddler, challenging everything we thought we knew about how galaxies develop. We'll also examine a potential threat that may be hiding in plain sight. Then, from the International Space Station, we'll look at the scientific treasures that just returned aboard SpaceX's Dragon capsule. And finally, we'll shed light on what literally turned on the lights in our early universe, as new data reveals the surprising cosmic powerhouses responsible for illuminating the darkness after the Big Bang. So let's get started with today's news. SpaceX is gearing up for what could be a pivotal moment in the Starship development program with its 9th test flight, scheduled for Tuesday, May 27th. Liftoff is targeted for 6:30 p.m. Central Time from SpaceX's Starbase facility in Texas, with the launch window extending to 8 p.m. This mission carries extra significance as it marks the first time SpaceX will reuse a super heavy booster, Booster 14, which previously flew during Flight 7 and was successfully caught by the launch tower, will make its second journey to space, a crucial step toward SpaceX's ultimate goal of full reusability. The previous 2 Starship test flights ended in disappointment, with both ships failing just before reaching second stage engine cutoff. Flight 7's Ship 33 experienced fires in the attic above the engine bay due to a harmonic response issue during ascent, while Flight 8's Ship 34 suffered a hardware failure in one of its sea-level Raptor engines, leading to a fire in the engine bay. Despite these setbacks, both missions saw successful booster recoveries, providing valuable data and hardware experience for the program. SpaceX has confirmed that the harmonic resonance problem from Flight 7 has been fixed, and they've implemented additional improvements for Flight 9. Ship 35 will be attempting to fly past the point where its predecessors failed, aiming to complete its full mission profile. If successful, it would represent a major breakthrough for the Starship program. The mission objectives remain similar to previous flights, with the ship expected to perform a splashdown in the Indian Ocean after completing several experiments. These experiments include deploying 8 Starlink satellite simulators, relighting a Raptor engine in flight, and testing various areas of the heat shield. The heat shield will feature metallic tiles, an actively cooled tile, missing tiles to test durability during re-entry, and tapered edge tiles between the aft flaps and catch points. While the ship's trajectory remains largely unchanged from previous flights, Booster 14 will follow a different path this time. Unlike Flight 7, SpaceX will not attempt to catch the booster, instead directing it to perform an experimental re-entry before splashing down in the Gulf of Mexico. The stakes couldn't be higher for SpaceX as they work to demonstrate that Starship can reliably reach orbit, a capability essential for NASA's Artemis program and SpaceX's own ambitious plans for Mars. After nearly 6 months since the last test flight, all eyes will be on whether the third time's the charm for getting a ship past the critical engine cutoff milestone. Next today, a deep space mystery. In an unexpected discovery that's reshaping our understanding of cosmic evolution, astronomers have identified a massive galaxy that stopped forming stars when the universe was merely 700 million years old, long before Earth even existed. This ancient galaxy, with the technical designation Ruby's UDS QGZ7, now holds the record as the most distant dead or quiescent galaxy ever confirmed. What makes this finding so remarkable is that galaxies typically need billions of years to grow large and then shut down their star formation. Yet here was this massive celestial structure that had already completed its life cycle in the universe's infancy. The powerful James Webb Space Telescope made this discovery possible, allowing astronomers to peer deeper into cosmic history than ever before. The galaxy managed to form an astonishing amount of stars in its brief active period, with stellar mass equivalent to more than 10 billion suns. Then, for reasons astronomers are still trying to understand, it simply stopped. All star formation ceased completely, leaving behind what scientists call a quenched galaxy. Data from Webb's near-infrared spectrograph confirmed this quiet state during observations conducted as part of the RUBIES survey, that stands for Red Unknowns, Bright Infrared Extragalactic Survey. The spectrum revealed no signs of ongoing star formation, instead showing strong Balmer and calcium absorption features characteristic of older stellar populations. When astronomers determined its redshift of 7.29, they realized they were looking at a galaxy as it appeared just a few 100 million years after the Big Bang. Further analysis suggests it had already stopped forming stars around 50 to 100 million years before the light we're now detecting left the galaxy. This means it likely completed its entire star-forming phase even before redshift 8, pushing our timeline of galaxy evolution into uncharted territory. The discovery challenges fundamental assumptions about how quickly galaxies can form and evolve in the early universe. Current theoretical models simply don't account for galaxies growing so large and then shutting down so rapidly in the cosmic dawn era. This finding suggests we may need to substantially revise our understanding of the processes driving galaxy formation and evolution in the universe's earliest epochs. What makes this discovery particularly remarkable is the galaxy's extremely compact nature. Despite its massive stellar content, RUBIE's UDS QGZ7 measures just 650 light-years across. To put that in perspective, our Milky Way galaxy spans approximately 100,000 light-years. This incredible density makes it one of the most tightly packed galaxies ever observed. Scientists believe this ancient compact galaxy likely represents the core of what would eventually become the giant elliptical galaxies we see in today's universe. These modern ellipticals are among the largest and oldest galaxies we observe, often found at the centers of galaxy clusters. The structure of RUBIE's UDS QGZ7 closely resembles what we see in the central regions of these massive ellipticals in our cosmic neighborhood. As Anna de Graaf, lead investigator of the RUBIES program at the Max Planck Institute for Astronomy, explains, the discovery provides the first strong evidence that the centers of some nearby massive ellipticals may have already been in place since the first few 100 million years of the universe. The James Webb Space Telescope has been absolutely crucial in confirming this discovery. Previous telescopes like Hubble and ground-based instruments simply couldn't see deep enough into the infrared spectrum to detect features like the Balmer break at such high redshifts. While the Spitzer Space Telescope offered some infrared capability, it lacked the resolution and sensitivity needed for definitive observations. Webb's revolutionary infrared capabilities have completely transformed our ability to study the early universe. Next up, a subject we keep returning to, and with good reason. While NASA has been diligently tracking near-Earth asteroids that could threaten our planet for the past 2 decades, recent research suggests we may have a significant blind spot in our planetary defense strategy. 20 years ago, Congress tasked NASA with finding 90% of near-Earth asteroids that could pose a threat to Earth, and they've made considerable progress. However, astronomers are now discovering a new category of potentially hazardous objects that have largely escaped our attention: asteroids co-orbiting with Venus. These Venus Co-Orbital Asteroids follow the same path around the Sun as our neighboring planet, but with a concerning twist: they can cross Earth's orbit. Currently, scientists have identified 20 of these co-orbital asteroids, but new research indicates this may be just the tip of the cosmic iceberg. What makes these objects particularly concerning is their elusiveness. Many of these asteroids remain hidden in the Sun's glare from our Earth-based perspective, making them exceptionally difficult to detect with conventional survey methods. When the Venus co-orbitals are positioned between Earth and the Sun, they become virtually invisible to our telescopes, creating dangerous blind spots in our monitoring systems. Perhaps even more troubling is the unpredictable nature of their orbits. According to the research, these asteroids exhibit what scientists call highly chaotic orbital patterns, with Lyapunov times of just 150 years. In astronomical terms, the Lyapunov time indicates how long it takes for an object's orbit to become unpredictable due to chaotic dynamics. This means that tracking these objects' trajectories beyond a century and a half becomes extraordinarily challenging. Lead researcher Valerio Caruba from Sao Paulo University explains that co-orbital status protects these asteroids from close approaches to Venus, but it does not protect them from encountering Earth. This creates a peculiar situation where objects that share Venus's orbit can potentially pose a greater threat to our planet than to Venus itself. The research team defines these objects as potentially hazardous if they have a minimum diameter of about 140 meters and come within 0.05 astronomical units of Earth's orbit. For context, an asteroid of this size striking Earth could release energy equivalent to hundreds of megatons of TNT, thousands of times more powerful than the atomic bombs used in World War II. Such an impact could devastate an entire metropolitan area. As we expand our understanding of these celestial dynamics, it's becoming clear that our planetary defense strategy may need significant recalibration to address this previously underestimated threat lurking in the orbit of our nearest planetary neighbor. In the early hours of May 25th, SpaceX's Dragon capsule splashed down off the California coast, successfully completing the company's 32nd commercial resupply mission to the International Space Station. The unpiloted spacecraft returned with an impressive haul. Approximately 6,700 pounds of scientific equipment, supplies, and experiments that had been conducted in the unique microgravity environment of the orbiting laboratory. This scientific treasure trove represents some of the most cutting-edge research being conducted in space today. The Dragon undocked from the station's Harmony module 2 days earlier before making its journey home, carrying cargo that could revolutionize everything from spacecraft design to satellite maintenance. Among the most fascinating returns was the MISSY 20 experiment, short for Multipurpose International Space Station Experiment. This project tested various materials by exposing them directly to the harsh conditions of space. The samples included radiation shielding, solar sail coatings, ceramic composites for re-entry vehicles, and specialized resins that might one day form the basis of improved heat shields. Mounted on the exterior of the station, these materials endured extreme conditions that can't be replicated on Earth: ultraviolet radiation, atomic oxygen, charged particles, and dramatic temperature swings that would destroy most conventional materials. By analyzing how these samples performed, scientists can better design spacecraft and satellites to withstand the unforgiving environment beyond our atmosphere. Perhaps the most visually striking experiment returning to Earth was ASTROBE REACCH, which stands for Responsive Engaging Arms for Captive Care and Handling. This innovative technology demonstrated something that sounds straight out of science fiction: robotic, tentacle-like arms capable of grasping and relocating objects in space. The system used specialized adhesive pads to capture items of different shapes and surface materials. This capability represents a major step forward in addressing one of the growing challenges in Earth orbit: safely capturing and relocating debris and defunct satellites. Such technology could eventually help extend satellite lifespans through in-orbit servicing and potentially reduce the hazardous debris field that increasingly threatens spacecraft operations. The Dragon's cargo also included some more whimsical but no less important items. Books from the Storytime from Space project are returning after orbiting the Earth. This educational initiative featured astronauts reading science and mathematics-related children's books while floating in zero gravity. The crew also recorded themselves performing science demonstrations that corresponded with the book's themes. All these videos have been made available in an online library with accompanying educational materials, inspiring the next generation of space explorers. Additionally, hardware and data from a one-year technology demonstration called Optica, onboard programmable technology for image compression and analysis, made the journey home. This advanced imaging system was designed to revolutionize how we transmit ultra-high-resolution hyperspectral imagery from space to Earth in real time, potentially transforming everything from disaster response to environmental monitoring. Together, these returning experiments showcase how the International Space Station continues to serve as humanity's premier orbital laboratory, developing technologies that not only advance space exploration, but also deliver tangible benefits to life on Earth. To wrap up today, let's look at a solution to a great scientific mystery that's finally been sorted. We finally have an answer to one of cosmology's biggest mysteries. What switched on the lights in our early universe? For decades, astronomers have been puzzled by how our universe transitioned from a dark, opaque fog to the transparent cosmos we observe today. The answer, it turns out, is surprisingly small. According to groundbreaking new data from the Hubble and James Webb Space Telescopes, it was tiny dwarf galaxies, that cleared the primordial fog of neutral hydrogen filling intergalactic space after the Big Bang. In the beginning, the universe was filled with a hot, dense plasma that scattered light, effectively making everything dark. As it cooled, protons and electrons combined to form neutral hydrogen gas. While this gas allowed some wavelengths of light to pass through, there weren't many light sources around to illuminate the cosmos. That changed with the birth of the first stars. Their radiation was strong enough to strip electrons from hydrogen atoms, reionizing the gas and making the universe transparent to light. By about 1 billion years after the Big Bang, the period known as cosmic dawn, the universe was fully reionized. Scientists had long assumed that the primary drivers of this reionization must have been powerful sources, supermassive black holes or massive star-forming galaxies. But the Webb telescope's unprecedented sensitivity has revealed a different story. By examining a galaxy cluster called Abell 2744, which acts as a cosmic magnifying glass through gravitational lensing, researchers were able to detect extremely faint dwarf galaxies near the cosmic dawn. Their analysis revealed something astonishing. These dwarf galaxies outnumber larger galaxies by a ratio of 100 to 1. Even more surprisingly, these tiny galaxies collectively emit 4 times more ionizing radiation than previously assumed from larger galaxies. Despite their diminutive size, they were extraordinarily efficient at producing the high-energy photons needed to clear the cosmic fog. As astrophysicist Hakeem Atek described them, these galaxies were truly cosmic powerhouses whose abundance and collective energy output was substantial enough to transform the entire state of the universe. It's a case where quantity truly overcame quality. Their sheer numbers compensated for their individual small size. This discovery fundamentally changes our understanding of how the universe evolved from darkness to light, highlighting how even the smallest cosmic structures can drive the most profound transformations in our universe's history. If confirmed across multiple observations, this discovery represents one of the most significant breakthroughs in our understanding of cosmic evolution. It suggests that the universe's most transformative processes weren't necessarily driven by the largest, most spectacular objects, but by the collective influence of countless smaller ones. A profound lesson about how even the smallest entities can collectively drive the most fundamental changes in our universe. And that's it for today's episode. Thanks for joining me on Astronomy Daily. I'm Anna, reminding you to visit us at astronomydaily.io, where you can find all of today's news and all things Astronomy Daily. And of course, remember to subscribe to the free podcast, available on all podcast platforms. I'll see you tomorrow for more fascinating developments from the final frontier. Until then, do as I do. Keep looking up.